Alright, kiddos, we're going to talk about exponents this week. We've got about 7 lessons on exponents, and this is the first one. You'll be able to do these just one right after the other. So after you watch a note video, get the assignment, and then finish the assignment, and watch another video. So here's the first one, Exponents 1 notes. Here's what the note sheet looks like. We're going to have 2 specific rules to talk about today. So let's take a closer look and let's get busy. Alright, Exponents 1 notes talks about the power of zeros and something called reciprocals. Now, each situation that you come across with exponents has its own set of laws. Alright, and there are certain exponents that you can allow to have, and there are certain exponents that you cannot have. And what the basics behind these laws is to simplify your problems to make them easier to work with. Alright? The first law we're going to talk about is the power of zero law. This one right here. And it basically says that if you have any power with an exponent of 0, it basically cancels out to equal 1. Alright? That means anything to the 0 power kind of tells you that it's not even there, and we know that if the number's not even there, if it's like an imaginary number in front of a coefficient or something like that, it's really a 1. Okay, that only works if the number you're talking about is not 0. If you have 0 to the 0 power, that's just 0. Okay, but anything else raised to the 0 power is 1. Doesn't matter what it is. Could be a million to the 0 power, it equals 1. Alright, that's probably one of the most simple rules that we have for the laws of exponents. Question number 2 talks about something called reciprocals. Alright, basically this happens when you have a negative exponent. You see right here this situation? I have a to the negative n. Whatever number could be that exponent. If it's negative, that's a problem. You can't have negative exponents. Well, to change the sign of an exponent, you move it down to the bottom of a fraction, or to the other side of the fraction. That's called a reciprocal. Alright? Basically what we need to know, or what you need to know, is if you have negative exponents, you need to put them on the other side of a fraction. Alright? I have a different kind of trick to tell you whenever we get to that point. Alright? But for right now, negative exponents, you got to put them at the bottom of your fraction. What if they're already at the bottom of a fraction? Like if we look at point B right here. If you have a fraction already, and you have an expression with an exponent, a negative exponent on the bottom of the fraction, to change that negative sign, you flip it up and move it up to the top of a fraction. Alright? Now here's the way I think of this. I think of negative exponents as bad kids. Alright? If you have a kid who's being bad, to discipline them, you put them in the basement. Alright? Not saying that I do that with my kids, because I don't. I'm just saying. Alright? But if he's being bad, you got to move him to another spot, and then he becomes a good kid. Well, if he's already in the basement and he's being bad, then to discipline him, you put him back up into the attic and make him a good kid. Alright? So, negative exponents are bad kids. To fix them, you got to move them. You either move them in the basement, on the bottom of the fraction, or take them up to the attic, at the top of the fraction. Now, if they're being good in the basement, then you're alright. You can leave them down there. They can just play whatever they're doing down in the basement. Alright? So, let's put these things to work. Question number 1 on your notes is 2 to the negative 2 power. Well, right off the bat, that is a negative exponent. It's a bad kid. Alright? If you have negative exponents, to make them positive exponents, you have to put them in the bottom of the fraction or send them down to the basement. Alright? So when you flip this thing around, you're going to end up with a fraction of 1 over 2. And now this negative 2 exponent becomes a positive 2 exponent. Okay? That's the reciprocal law. All right, bad kids, put them in the basement. Now, once they're in the basement, you can do the work. 1 over 2 to the second power is actually 4. It's 2 times 2. That's your solution. Once you simplify it, you can actually work it out. All right, what about question number 2? Question number 2 has negative 4 in parentheses to the negative 3. Well, this whole thing right here is a negative exponent, and it has a negative exponent power. Well, it goes down in the basement. All right, so let's flip this fraction around. 1 over negative 4 in parentheses, and now that negative 3 exponent can change to a positive exponent. You put a bad kid down in the basement, he behaves. Alrighty, now we can actually work that out. 1 over negative 4 to the third power, that's like negative 4 times negative 4 times negative 4. 3 negatives is going to make a negative. And 4 to the third power, if you stick it in your calculator, you're going to get 64. And that is your answer. Some of you might be saying, hey coach, that 64 is negative. He's a bad kid. Let's put him in the attic. Well, no, this 64 right here is not an exponent. This is an actual number. And negative numbers can stay where they go. They don't have any laws of exponents. All right, question number 3. All right, here is 5 to the 0 power. Well, remember, anything to the 0 power can basically just cancel or reduce down to 1. I don't care what it is. It could be a negative 5 to the 0 power. It's still 1. That power of 0 changes anything to 1. Okay, a couple more problems. Turn your page over to the other side. Question number 4 has 3y to the negative 2 power. All right, now here's the thing. Your power, your exponent, only has control over what it's attached to. And right now, it's only attached to the y. It's not attached to the 3. All right, so the only thing that's being squared right now to the negative squared power is the y. So that is the thing that needs to be simplified. All right, and y here has a negative 2 power, so he needs to go down into the basement. The 3 can stay. The 3 doesn't have a negative exponent. 3 is just 3. All right, so 3 stays on the top, and the y, since he has a negative 2 exponent, we put him down in the bottom, and now he has a positive 2 exponent. And if anything left over can be simplified, you need to simplify it. But right now, I just have 3 on top and y squared on the bottom. That is simplified. That's all you got to do. Remember, you cannot have negative exponents in your solution. Let's keep going. Question number 5 has negative 4 over k to the negative 4 power. Now I know some of you are thinking right now, hey coach, there's a negative 4 and he's a bad kid, but is this negative 4 right here, is he the exponent? Or is this negative 4 the exponent? This negative 4 right here is the exponent. That is your negative kid. That's your bad kid. All right, and he's being bad in the basement. So if he's being bad in the basement, we need to move him up to the attic, up to the top of your fraction. All right, this negative 4 up here at the top, he's a regular old number. All right, you can't control negative numbers. They just got to stay where they are. They're negative numbers. So we have a negative 4. He stays on the top of the fraction. And this k moves up to the top. And now his exponent can become a good exponent, a positive exponent. All right, and again, that 4 right here is only attached to the k. We cannot take this negative 4 and raise it to the 4th power. We can't do that. All right, so this is as simplified as we can get right now. All we did was move bad exponents where they're supposed to be. We did the reciprocal law. Now check out number 6. I see some bad kids. I'm going to circle them. And I see a 0 exponent. Remember, 0 exponents can reduce out. Basically, they just cancel away. They reduce to 1. All right? And bad kids, negative exponents, you got to move. All right? Now, you might be saying, hey, what about y to the 5th power? Is he a bad kid? No. He's a positive 5 exponent. He can stay where he is. He can stay in the basement. All right? So when I'm ready to write my answer, I know that these two guys are going to stay in the basement, which leaves nothing left on top, but technically that's an imaginary 1 on top. And we bring down our x to the 3rd power and y to the 5th power, and you must write it in alphabetical order. The x to the 3rd goes first, then the y to the 5th goes next. One more problem. Let's see what comes out of it. Alright, for problem number 7, here is a 0 exponent. I know that 0 exponents cancel out to 1, so I'm just going to cross it out. I see a negative exponent. I know that this b is going to move down to the bottom. But when I look down at the bottom, I also see that this c right here has a negative exponent, so he's got to move up to the top. Okay? So I know what's going to happen to all of these exponents. Now we just got to write the outcome. All right? The a went away, and the b moved down to the bottom. All right? But I know that the c moved up to the top. So let's start off with the c. When we bring c to the negative 3 up to the top, it's actually going to become c to the positive 3 over. Down here on the bottom, I'm going to have d to the 6th, and the b comes down here. The b to the negative 2 comes down there and becomes b squared. Well, remember, you've got to write it in alphabetical order. So the b squared goes first, and then the d to the 6. Now, once you have everything moved, double check and make sure you don't have any negative exponents or 0 exponents. And if you're good, then you're done. This is your solution. Everything that needed to be moved is moved. Everything that needed to cancel was canceled. That's some rules on exponents.